Okay, well, looks like we might have a very small class today. But again, I will be posting this online afterwards. Please make sure that you have said hello, hi, something in the chat box. I did not see who was just named iPhone. Does the person named iPhone have the ability to enter anything into chat? If you do, please do. Oh, well, I'm not sure if they have the ability to do that. So today I had said, I don't know if you guys had read my message on Edsby, but I said that for today's stuff, I was going to focus on going over some of the problems that were on the worksheet from the other day. Specifically, I wanted to talk a little bit more about some of the ones that involved like tables and stuff, because on Monday it said that I wanted to focus more on the tables during this lesson. For the rest of this week, I haven't finished working out the entire calendar for this class yet, but just to give you an idea of what we're going to be doing. So today, again, we're going to be doing this lesson, going over some of the stuff from the last worksheet. Tomorrow, there will be another worksheet. Again, I will also hold office hours tomorrow if you have questions. And then on Friday, there will be a very short review over the worksheet from Thursday, and then there will also be a quiz posted as well. Now, what I've decided to do with quizzes, I'm going to actually post quizzes and leave them open for a couple days. So again, you don't have to necessarily get done on Friday. So anytime I have a quiz or a test or something scheduled for a Friday, I will leave it open from Thursday through Sunday. All right, so that you have a chance to take it. So again, anytime we do a test or a quiz, I'll leave it open from Thursday through Sunday. So there'll be 4 days where you could log on and get it done. Somebody else is waiting. I don't recognize the name. Also, as you came in, you probably noticed that you went into some sort of waiting room. They've asked us to use the waiting room feature so that we can identify who's there before we let them in, because there have been some issues with people coming into random rooms. So let me just message this person real fast. Sorry, I had somebody waiting in the waiting room that got wait to let in. Again, when you come on, please try to change whatever your name is on whatever device you're using to your name, so that I can recognize it and I can say that, yes, it's safe to allow you to participate. Because again, there have been some issues. Anyway, going over some of this worksheet. So the worksheet from yesterday that I had posted online. Again, you can find that worksheet in a couple different places. It is on Edgenuity attached to the assignment, but it's also posted in my folder on the OneDrive as well. So again, you can always get to that from either one of those places. All right, now for the worksheet that we had, all right, I'm gonna let this person in and then see who it is. Anyway, while I'm waiting for that response, for the worksheet, let me share a different screen than what's currently up so that you guys can see what I'm seeing. All right. Okay, so for this worksheet, the first part of this was just identifying correlation. So hopefully that part was fairly easy. You just had to say what type of correlation it was. You should also have said what type of function. So there's a lot of different things that you could have said about some of these graphs. For example, on that first one, since the general just is it keeps increasing, going up, it's definitely a positive correlation. But is it going in a straight line? No. So we had a couple different types of functions that I had mentioned. The ones specifically were linear, quadratic, and exponential. Well, for that first one, that's more of an exponential function, because an exponential function slowly goes up at first and then sharply increases. Let me write on here so that we can see. So again, if we were to draw a line on this, like a line of best fit, it would go something like this, and then sharp increase. That looks like an exponential function. Now, for number 2, those points are everywhere. Let me let this person in. Those points are everywhere. So that one has no correlation whatsoever. Again, they're just randomly plotted all over the place. We can't even tell if it's going up or down. They just seem to be randomly going back and forth. So whereas the first one had I would say that this is a strong, positive, exponential, this one has absolutely no correlation. All right, so number 3, now that one is, again, I'd say it's pretty strong, and you can definitely see it's going down. And for the most part, it's a pretty straight line. So if we drew a line, again, that's not perfectly straight, but again, there's definitely a strong negative linear correlation there. So those are the main words that you could use to describe that. So number 4, this one is kind of the opposite of number 1. Again, it's also strong. It definitely has a correlation there. It's going down, and it's an exponential again, but it's an exponential decrease. So when you have an exponential function, you can either see a positive or a negative. This would be a negative because it's a decrease in exponential function. So again, strong, negative, exponential. So hopefully that part of the assignment was easier. But then you had some graphs, not some graphs, some charts as well. The chart part might have been a little bit harder. So let me move this up. Oops, clear that. So now down here, these didn't give you a graph. So since they were giving it to you as a chart instead of a graph, one way that you can tackle these is do a quick sketch as to what it looks like is happening. So again, if you can't visually see it, it's going to be hard to do. So draw your own graph. So first thing that we're going to do here, number 5, I would draw myself a nice little X and Y axis. We have the first couple are all at 100. Let's just say it goes anywhere from 100 to 1,000. So let's just say this is starting at 0, this is starting at 1,000, and I have roughly 500 somewhere here in the middle. Again, it doesn't have to be a great graph. The numbers on the sides for Y, it goes anywhere from 2,000, and then the biggest number is 9,000. So I'm going to start again at 0. I'm going to go all the way up. I'm going to label this as 10,000. Then I'm going to put 5,000 right here in the middle. And then that way we can go ahead and plot some points. So I have at 100, which might be about here. I have a point at 2,000, so maybe right about there. Another point in the exact same place. Another point just above it at 3,000. Then we have at 200, we're now at 4,000. At 400, we're now at 7. Let me add this person back to the room. Now, if you get knocked out of the room and you re-enter, just know, again, with our new security policy that we're doing where we have to have you guys go in the waiting room first, anytime you leave the room, I'm gonna have to allow you back into the room. So make sure if I don't catch you right away, because again, if it's in the middle of a session, not right at the beginning, I might not see you enter. So send me a message and remind, or send me a text to my Google Voice number. That way I will see that you're out in the waiting room waiting, because again, if I'm in the middle of talking, I might not notice it right away. All right, picking up where I left off. So again, we had at 400, we have about 7,000. Then at 5, we had about 8,000. Another one at the same point. Then we had at 700, it's at 9,000. And then at 900, it's at 9,000. And then it's actually at 8,000. So this graph is actually, it was increasing almost the entire time, and then it leveled off and started going the opposite direction. So if I was to draw a function to represent this, it looks something like this. And the only function that we're talking about here that fits that is a quadratic. If we kept going with that same pattern and kept going, then again, this is going to give us the shape of a parabola. So this is a quadratic function. And I have some disagreements with what the answer choice in the book, in the worksheet said. They said it has a positive correlation because it's going up from left to right, which I agree. The majority of the points are positive. So I'm going to say positive as well. If we're specifically talking about correlation, the correlation here is positive. However, if we look at, instead of looking at just the correlation, what direction the points seem to be going, and look at the function itself, this function is a negative quadratic function. So that's a little bit confusing, but the points that we have on the graph, for the most part, are going up. So they're saying a positive correlation. Again, positive correlation. And that it is also a quadratic function. So again, a little bit confusing, but positive correlation, quadratic function. But that's what you could do for each one of these. So number 6, again, it gives you a negative linear, 7 was a positive quadratic, and then 8 was absolutely no correlation. The points just jump all over the place. So let me look at 2 of these other graphs real fast. Again, they don't have to be superstar graphs here. If you didn't label your axes too, that's fine. But we can roughly say that, all right, we have a point at 200, that's at 4,000. So I'm going to draw a point there, then it goes down, then it stays down. Then we have, whoops, sorry, right there. Then at 5, same thing. At 5, same thing. At 6, 2. At, maybe I should have spaced these out more. It's hard to see with the way I'm doing that. Nope. Nope. Sorry, still getting used to this. Let's space it out a little bit more. Because on this axis, if I did 5,000 as the top number, we'd have a much easier view of this. So from 4,000 to 3,000, 3,000 to 3,000 to 2,000 to 1,000, we can see that the general gist of those points is going down, and it's roughly in a straight line. Again, you don't have to get fancy with the graphs. I'm not asking you to have something perfectly accurate. Again, the overall question here is, what type of correlation does it have? So again, all you really need to know here is that you have a negative linear correlation. All right. So let's go ahead and take a look at another part of this, because the second part was much harder. All right. You had the SAT style questions. And again, we're still going to be doing SAT style questions. You're still going to be doing some Khan Academy and things like that. So next week, again, we'll have a week where we have mostly online material from Khan Academy for the assignments. So next week, there won't be a lot of live instruction like this. I'll still hold the same time slot, but I'm going to basically leave it open so that if you have questions, you can come on and ask them. And for next week for this class, you won't have to actually come on if you don't want to. Again, I just want you to check in with me at least once through the week next week live, but most of the assignments for next week are going to be on Khan Academy. So if you don't remember how to do something with Khan Academy, I'm going to start off each live session next week by showing the steps on how to get into Khan Academy in case you forgot how to get into it and where to go. And I'll be showing it through Clever as well as my personal login. So I'll show it both ways. Again, you can get there either way. But again, that's what next week will be consisting of more, is the Khan Academy work. But again, I'll still hold hours so that if you have questions, you can come on and I can help answer them. All right, so for the next part here, we have, let me clear this, move this up, there we go. All right, so on here, and you have a graph that they also ask you to say which equation you think it is. So in order to say which equation it is, you're going to have to do a couple of things first. Essentially, you have to figure out that line of best fit and then look at that line of best fit and say, all right, now that I have a line of best fit, what is it going to be? So I'm going to try to draw a line on here the best I can using some of the tools that are on this program. So we have a rough line there of where we think the line of best fit could be. Again, I just drew it randomly through those points. Now, looking at the equations, we should be able to say, all right, which one might it be? So you have several options. If we look at where the x value is, or sorry, the y value is, where it's intercepting the y-axis, that's way up there, somewhere around between, I'd say, depending on how you drew a line, it could have been anywhere between 8,000 and 10,000, right? So if we go down here, I would say the last option probably isn't going to work there. Neither is D. Well, and D's kind of off the screen. D definitely won't work, so D's out. But we do still have possibilities of A or B. So we need to take a look at 2 points and see how much does it change by for every single unit. So I'm going to go with this point right here on the line, and then this point right here, because this is at 2, this is at 3, and I can see it roughly went down about 500, right? The change here, the change from here to there is 500 in negative direction as it went over 1 unit. So negative 500 is roughly my slope. So since negative 500 is roughly my slope, look at those 2 answer choices that were left. The only one out of these 2 that is close to being correct is this one. So, and I'd say that where I have the intersection is, that's pretty close to that as well, because you had my line looks like it's just above about 8,500, which this had a y intersection of 8,593. All right, so A would be my answer choice. Now, same thing for the next one. So on the next one, we have what looks like a quadratic equation, and it tells us that we have a scatter plot, and it tells us in the problem that it is a quadratic. So I'm going to roughly look at this by drawing a line through here. That'd be a quadratic. It's going to look something like that. Now, what they're asking us for is, what does the vertex tell us about U.S. gas prices? So when we talk about the vertex on a quadratic, we're talking about this right here. All right. So the vertex in this case is the lowest point on this graph. So the lowest point is telling us where gas was essentially the cheapest. And if it's the cheapest there, it's not only telling us that what the cheapest value was, but then the X value is telling us at what year. So roughly, I would say that the, let's see, year since 1980, it says. So add 15 years to 1980, and you get 1995. So I would say that this point is roughly at the year 1995, and we have a gas price of roughly $1, let's say $1.30, $1.25, somewhere in there. So if we look at the options there, the only one that is really close to telling us what we have, well, it can't be A, it can't be C, because A and C both use the word maximum. So since this one uses the word maximum and this one uses the word maximum, those two are definitely out. B says that in the year 1997, the price for 1 gallon of gasoline reached its exact minimum of $1.33. Whereas D says in approximately the year 1997, the price for 1 gallon of gasoline reached its approximate minimum value of $1.33. Well, did we know for sure exactly where the minimum was? No, this is a scatter plot. It doesn't tell you an exact value. The line that I drew isn't exact for everything. So on this one, you're going to have to say that it's an approximation. So D is the only thing that works as a correct answer, because again, D is saying that's an approximate value and it's not exact. All right. So this section, again, required a lot of different ideas. Let me go down to the next one, because the next two are charts and they're very different from the other problems that we've had. So now, let me see if I can zoom in on this a little bit. Move this, zoom in on these two. All right, so for the next one, it says enrollment trends in biology focused programs. And it said a biology professor is investigating trends in current enrollment of male and female undergraduate students. Well, in this table above, some of the information is given, but not all of the information is given. And it wants to know about how many female students should be enrolled in the forensics program to provide evidence that enrolling in forensics is independent of student gender. So if we are looking at enrollment for females in the forensics program, so that's right here. If we want it to be independent of gender, roughly half the students have to be male, half the students have to be female. So if the total number of people in forensics is 214, take that 214, divide it in half, and you'd have 107. So these two spots have to be somewhere close to 107 if there's not going to be any type of bias because of gender. So if we look at the options, the only one that's close to that number is B. So B could work as a value that shows that it doesn't matter what gender you are when registering for the forensics program. Again, it had to be split almost half and half. All right, again, some of you guys just joined as I was talking in the last couple questions. As you join, again, in case you missed it, you're going to be going into what's called a waiting room. So it's going to show me who you are before I add you into the class. Please try to make sure that you have your name showing so that I can verify that it's you before I let you in. Again, they wanted us using the waiting room feature so that we're not letting people in that don't belong in classes. Also, it's very important that once you enter the class, you send me a message so that I have a record that you attended one of these meetings. All right, let's do number 4. Let me get my windows out of the way here. I know you can't see them, but my chat boxes are covering all these other windows. Okay, so now number 4. This one is a little bit different because it's a free response. It's one of the few questions on here. There weren't many that were free response. I think there's only a total of 3, but it was one of the few free response questions. So again, they gave us another table, but there's information that's missing. So we need to figure out how many homes is it for, let's see, if only 4.5% of non-historical protected homes have a field, stone, and mortar foundation, how many homes is it? So important pieces of information here. So it said it is historically protected. So it's going to be from this category up top. And it said that we want this number here. Well, this goes back to what we did right before break because they gave us a percentage that needs to go in this spot. So on here, we have a total. We know what the total is. And this has to be a percent of this total. We don't care out of this total. We don't care out of any of these other totals. The only thing that this question is asking about is out of the let me reread the question. I may have circled the wrong blank. So it said if only 4.5% of the non-historically protected homes. Something that's tricky about that question is that non is on a separate line. So when I read it the first time, I read historic. So be very careful. Because if that was to happen on a test, again, it says non over here, and then there's a dash historically. So that changes which value I'm looking for. I'm actually looking for this value instead. So I'm not going to be using the total that I originally said. Not this total. It's going to be this total. So out of the non-historic properties. So we have 4.5% of 134. And again, you can just multiply those. Now, if you're using a calculator that doesn't have a percent key on it, again, you have to move the decimal. So it'd be 0.045. And then you're multiplying it to that 134. So if you multiply that out, 134 times 5% equals, it's only 6.03 houses. So since it's, see, round to the nearest whole number, it says, so we'd have to round that off to 6, and 6 would be our answer. All right. Okay, so I did a couple of the different types of problems. Was there any other specific questions that people had for me today? Again, if you had missed the beginning of class, I had said that for this week, we will have a quiz that I'll post on EDSB, it'll be through an office form. You'll just click on the link and then answer the few questions. It doesn't have to be done on a computer, but I'll leave it open from, on the calendar, it'll be for Friday, but it'll be open from Thursday until Sunday, the actual form for the. Let's see, thanks for reviewing the questions. Okay. So were there any other questions that anybody had at this time? I know in a couple of the messages that I had got from on Edgenuity, people had just asked if I could go over some of these, which that's what I had planned on using a little bit of time for today. I won't always do that with live class time, go over questions. Again, if you have any specific questions, you can come see me during office hours. During class time, if I'm going over questions, I'm usually going to try to stick to ones that I specifically think we need to go over as a class. But if you have any other questions on any other worksheet that I may assign or any other problems, again, just ask me during that time on Tuesdays and Thursdays. Also, just be aware, my time on Thursday, as of right now, Tuesdays and Thursdays, I have the same time from noon to 1:30. There's a chance I might have to change my Thursday time because I have a meeting that's going to be a recurring meeting on Thursdays at 11:30. So I need to see how long those meetings are supposed to last, and then I may have to move that time. But again, if there's no other questions, that's it for this class time. Again, next week I'll be on, let's start off with Friday. Friday, again, I'll be on for Friday's class time. I'm going to go over a few questions from the worksheet that I post for tomorrow. So again, like I said, there's going to be a new worksheet for tomorrow. I'll post that first thing in the morning or maybe even late tonight. And then for Friday, again, it's going to be a quick review, and then there's a quiz. So the part that you have to turn in for a grade is the quiz. Now, if you want to do the quiz ahead of time on Thursday, if you don't want to wait for the review, that's fine. I'm going to have the quiz up from Thursday through Sunday, so it'll be your option as to when you want to get it done. All right. And then next week, starting Monday, Wednesday, and Friday, when I come on for class time, I'm going to make sure I go over instructions on how to access Khan Academy, but the assignments for next week will all be through Khan Academy. So there's not going to be any new notes during next week. So again, I'll be on during my live times, but mostly just to help people figure out how to access Khan Academy and things like that. If they're having trouble, again, I can help you with that. All right. Any other questions? All righty. Well then, have a good day, and I will be on tomorrow for the office hours, and then I'll see you guys on Friday to go over the worksheet. Have a good one. And if you didn't already say something in the chat, say something in the chat before you leave so that I can record you as being present for this live feed. Okay, I'm going to go ahead and end the meeting now. Have a good day.